Hey guys, my name is Fabian. I've been with Yahoo Search in the last almost 2 years, first working on Search Direct and now working on Yahoo Axis, for which we decided to shoot for this completely new platform built on top of Node.js. So when bringing such a new platform to the scale of Yahoo Search, obviously there are a lot of challenges, and I'm planning to share some of those challenges and how we solved them today with you guys. So one big challenge for us that came up probably halfway through our project was that after we decided to separate our application into different pieces, into different applications, how can we reuse code between those applications, and also as other teams at Yahoo start to use this new platform, how can we avoid solving problems again that other organizations and other teams had already solved for us? Another challenge was how can we enable ourselves to react quickly to unexpected situations and changes? And last but not least, we had to make sure that this new platform not only performs well, but also scales well and is stable. So first, we're going to take a look at the code reuse challenge. So how can we enable different teams developing different applications in different organizations to safely reuse each other's code? Because I think everyone who's been developing software before knows that when you update your dependencies, when you update the code that you pull into your project from other people, what happens is that sometimes your application stops working, even though you had not changed a thing, just because some shared code changed, maybe an API changed, and now your application is broken. So we're going to try to mitigate that and try to safely share our code. Now, obviously, what comes to our mind when we talk about Node.js and how we can share code is the NPM. NPM is a package manager for Node.js packages. The cool thing about NPM is that it offers a lot of functionality that increases the convenience of using it. So for example, it resolves dependencies automatically and recursively. So if you pull in a module that depends on 5 other modules, it can download all of those dependencies and install them automatically. That's also because NPM has a registry, which is a repository of all available packages, and this is a central registry, and you download your packages from there, and you can publish them there as well. So I'm sure a lot of you guys already knew this, but just to make sure that everyone is on the same page. Now, Mojito introduced NPM support a while ago, and how it works is that just as other applications, Mojito has its package.json file, which describes the package and therefore also describes the dependencies that this Mojito application requires to run successfully. So in your package.json, you can list any module from the public NPM, or you can also list any module from our internal NPM, about which we will talk about later briefly. And the cool thing is that Mojito is aware of NPM, and it pulls in not only Node.js modules, but also Mojito resources from the Node modules folder of your application. And that helps us a lot because, as you can see, Mojito resources are quite powerful. So a Mojito resource can be a YUI module that in the Mojito documentation would be referred to as an autoload, most likely. But also, you can pull in Mojito add-ons. Now, what is a Mojito add-on? Mojito has something called the action context, which is an object that represents as a developer, your main entry point into the Mojito framework. So when you write a Mojito add-on, you enhance this action context. And on top of being the entry point into the Mojito framework, the action context also provides, as the name says, context about the request that is currently being handled. For example, the cookies that came in with this request, and so on. So let's say I want to write an add-on that gives me more advanced information about a cookie, like for example, it passes its data. So I would write that as an action context add-on, and my add-on would annotate the action context to provide more advanced information about this cookie, except just an unpassed string value. And last but not least, you can also share full mojits via NPM. Now, a mojit is a model view controller piece, self-contained, that you can pull into your NPM application. Probably you have a common way of doing editorial. You have a database where you store all that, and then one approach would be you have a central editorial tool and your application accesses this database. But another way, for example, would be to have a mojit that you can pull into your application that provides a special entry point, maybe /editorial for your application, where the view from this mojit displays the data in an editable way, so that you have a more self-contained approach to an application. You don't depend on a central editorial tool anymore. So that's kind of the power that bundling Mojito resources as NPM packages can give you. But unfortunately, there are some problems with NPM dependencies because, for example, at Yahoo, as it was already mentioned, we have the Manhattan Cloud. So when I deploy a package to the Manhattan Cloud, meaning that I run this application on this cloud, the cloud will download all the dependencies of my application and will then try to resolve them. So I've put an example dependency descriptor here. As you can see in the way I've specified the dependencies, for example, for YUI, if YUI 3.6 is released, I redeploy the same package. Now I get YUI 3.6, and maybe my application doesn't work with that version of YUI. I don't know. So that's one big problem. We can mitigate that by either specifying the dependencies with an equals notation that's safe from a deployment perspective, but NPM shrink wrap is today what is recommended and preferred. What shrink wrap does is that it looks at your application as it is installed locally and how the dependencies are satisfied, and then kind of locks that state down so that it will, every time you deploy it, you deploy that state. So even if, in this example, the red line, the YUI dependency, even if that would update, if you've shrink wrapped it, it stays the same. But then there's even one more problem. The NPM registry allows authors of packages to replace existing packages. So if I'm an author of a package and I replace the same version with a new package, the package changes. The code that you pull in changes, even though you think you've locked down your dependencies. And one solution is that you actually also keep your node modules, your dependencies in your SVN or wherever, and you make sure you have copies of those dependencies, which is probably not as nice as what we do internally. Internally at Yahoo, what we do is we have our own NPM package registry, and that registry provides the feature of immutable packages. So once I publish my package, I can only publish a newer version, but I cannot modify the already published package in any way. So that removes the need for keeping dependencies in the source tree. And another kind of security, or well, not security, a kind of a quality bar that we built in is that no one is allowed to publish to the NPM registry. Only the build system is allowed to publish to the registry. And this ensures that what actually the build system does is when it's building a package, it first executes functional tests and as well as unit tests. And for unit tests, it ensures that there is a certain amount of test coverage and no test failures. So as an employee, when I'm searching for some code to reuse, I don't want to be bothered with a lot of packages that were pushed there once and maybe they are all broken and I thought they do what I want, but they don't, and so on. So by having this high quality bar, if I find a package, I can be fairly certain that it really does what it says and that the code has unit test coverage, it has very high unit test coverage, and it has even functional test coverage. So that is, from an engineering perspective, is very desirable, I think. And then when I want to, as a publisher of a package, if I want to publish a new version, I increment the version in package.json and check into the repo, and the build system detects that and will republish the package. Another thing, as I said before, we sometimes need to be able to react as fast as possible to certain unexpected situations. One way to achieve this is by using dynamic configuration in areas where we expect such short notice changes to be necessary. For us, as engineers at Yahoo Search, we say that in our understanding, dynamic configuration means being able to change application behavior without a redeployment. Now, normally in Node.js applications, you specify your configuration as a JSON object in a JSON file. So, and you then check it into the repository, you wrap it in the npm package, and you deploy this npm package that contains the config. So if we want to do dynamic configuration, we need another way to get this JSON configuration data to the server. One thing, if you want to play with doing dynamic configuration, you can use YQL storage, because YQL storage can hold JSON data, and you can easily retrieve that. So I have a small example for you, how to do dynamic configuration through YQL. I've removed all the boilerplate code from the top and bottom, so you could put that in any Mojito add-on or in a YUI module or whatever else, and you could plug it into your application. So what I'm doing here is that when configuration is requested through this method in the very first 5 lines, I'm checking the cache. And if this configuration is available in the cache, and the cache is not older than, let's say, 10 minutes, we immediately call the callback and we return. So we don't lose more than a few milliseconds here. Only every 10 minutes or so, we really make the call in this example through YQL, where we use YQL storage to retrieve the config, and if we successfully retrieve it, we put it in our cache and we call the callback. Now, of course, you don't want your application to fail just because your configuration service, whatever you use, is not reachable. So if the cache is old and we cannot download a new config, at least we can continue with the old config that's in cache. That's better than crashing. So that's what we do here. You can see that if in the if-else on line 13, if result is not set. I think this is a very neat example of how Mojito, YUI, even YQL, how all those technologies come together, and then because it's JavaScript and we have the same runtime on both client and server, you can have that code on the server or the client. It doesn't matter. And also, while we were in this 1 year of bringing the platform to Yahoo and building Axis, there have been interesting changes. So one is that Node.js 0.6 got released. And cool thing is that for Mojito users, if you have a Mojito application, the change is transparent. For us, we didn't notice anything in terms of that. Our application was just fully functional as we tried it the first time. On the other hand, though, Node.4 had some serious problems that affected us. For example, the HTTP API does not honor timeouts correctly sometimes, and it also does not It does not make the socket, the underlying socket of the HTTP connection available as it should have done according to the documentation. So that was some problems that we ran into. Also, there was no DNS caching because it used something called CRS, which is an asynchronous DNS resolver that bypasses the OS and therefore also the OS cache layer. And so there was no DNS caching. So every time I call a backend, it makes a DNS request before calling the backend, which is kind of unexpected. Some of that was also because we were using YUI 3.4. Now with YUI 3.4, we actually got a lot of cool improvements on the server side and in Node.js. YUI 3.5 is the first YUI version, I guess, to officially support Node.js, where we have an official package, official documentation, and so on, which is a good thing, and it's convincing that, as an application developer, what you are using is a kind of first-class usage of the library, and it's fully supported and so on. One thing that the YUI team decided to do is to remove the JS DOM dependency on the server. So by default, when you instantiate YUI on Node.js, there is no DOM, which means that every module that requires the DOM will not work as expected. However, you have the ability to inject the DOM there in the links at the bottom. I will put my slides online for sharing. There, it is explained how you can inject the DOM dependency into YUI test. That's, for example, important if you are running server-side unit tests as convenience. For example, we do that because as a developer, it's much easier to run a unit test on the command line than opening my browser and then going to my YUI test page and reloading it and so on and so forth. Then another important and big change was in y.io. So because the DOM is gone, you cannot require I/O on the server side anymore because I/O has a module that tries to create an iframe later on. So this module will lead to a crash. So but that's not a problem because you can require I/O minus space, which would have been the right thing to do in the first place, I guess the YUI team would say, and then everything works as expected. And the cool thing is, while you have all the syntactic sugar of YUI, YUI now uses a framework called request as transport layer on Node.js, and you can specify arbitrary options for request so that YIO hands them down to the transport layer for you. And that's really cool because y.io was not supporting some things in 3.4, like proxying requests, which actually we needed on our MacBooks, for example, but now it supports that because I can hand down the proxy option to request. So that one is a little bit unexpected. I thought I could get away with talking about Node 0.6, even though it's a bit older, but then today they released 0.8. So I have to update you guys here. So what I did is I just downloaded 0.8 and I tried to run one of our biggest applications and crashed right away. So what I did is I checked, and luckily I only had to fix one single require statement in the Mojito package. There was one require of, I think it's sys, and that's now renamed to util. So I changed that single require statement, and then our application was running, and it was answering my search queries, and I was getting responses, and it looked all fine. So, I mean, that's by no means an official announcement, but I think looks pretty good so far, and it really shows how nice Mojito is, what kind of great job they are doing. That it's a seamless, or almost a seamless change for me as developer to update my Node version. Another thing we have to look at when introducing a new platform, and that was also a biggest challenge, probably the biggest challenge when we were trying to reach our goals, was performance. For example, Dirk and also Matt over there, they've been helping with that. They've been helping me a lot, and they've been bearing with me while I was like at night and bugging them a lot. So what we did is we created, we have this, if you remember Search Direct, it's where you type on the Yahoo search page, and then you see this, as I've highlighted it in purple over there, this what we call the rich panel. The rich panel displays some information about my search query. So here you can see I searched for Santa Cruz, and then the rich panel will recognize this is a city and a travel destination, so it shows travel information for Santa Cruz. And so we had that implemented in PHP for Search Direct, so we re-implemented it in Node.js, and we also, with plain Node.js, no Mojito, nothing, and we also re-implemented it with Mojito to get an idea about how the performance is on the 3 platforms. Now what you have to do when you want to render this rich panel is you receive a request, you get the query string, and then you call one backend. That backend says, hey, that's the data for this query, the rich content, and then the rich panel implementation will create this HTML and CSS. It's pretty simple, but a use case that we have all the time, like calling one backend and then proxying the response. So what we found out in terms of performance is that it's CPU bound for all 3 implementations. So both Apache, Mojito, as well as Apache with PHP, Mojito on Manhattan, and normal Node.js on Manhattan, they are all scaling until CPU usage hits around 100%. And kind of the bottom line of our analysis is that we found out that with Mojito on Manhattan, we can serve about twice the amount of requests per second at about half the latency compared to Apache and PHP. Here we have a chart which heavily summarizes this huge analysis. You can see in red the PHP implementation. We show latency over concurrency. So as concurrency goes up and latency stays stable, and if the line is flat, that's better. That means when concurrency increases, requests per second increases, but there is no latency increase. If, at the other hand, as you can see in the red line, almost from the very beginning, latency goes up linearly as concurrency increases, that means that you are actually not serving more requests per second. You are only serving them, only the latency goes up, but requests per second is actually the same. So you can see Node.js, the green line, is the most scalable one and with the lowest response time, and Mojito is already in the middle. The data here is a bit old, so maybe Mojito is doing even better right now. And all right, cool. I will test that tomorrow. And also, we will see future improvements with Node.js 0.8, where they promise a huge performance benefit and so on. So I'm very sure we will get that further down and down. If you are interested in that, we all just approach me later. We have more numbers that we shared in the past. In terms of stability, I can say that after this performance analysis, we were very confident in the platform. We saw that it serves hundreds of thousands of requests, and it can serve high concurrencies, and it doesn't crash, and it's stable. And this has been, like, we've proven this now after the launch, that this is really the case, like, that the cluster is running fine, Node.js is doing well, and we see the latencies and the response times that we expect. There is nothing wrong with it in any way. We've never been offline and so on. So today we serve hundreds of requests per second, and we serve static HTML and CSS, but we also serve dynamic pages, and we also have API entry points. As you can see from, for example, Karidi's talk, we have native pieces, they use APIs. We have other pieces that use APIs as well. And then in terms of monitoring, especially since this is a completely new platform, it's important to make sure we know what's going on. We monitor not only basic values of our cluster, such as CPU, memory, utilizations, and so on, which is provided by Manhattan, by default, but we also monitor custom we can monitor arbitrary values or any arbitrary metric. So every time we call a backend, we record how long did it take, was it successful, and so on, so that if things go bad, we have an alert right away and we could fix it. So this, so it has been a successful launch from an engineering perspective. We didn't have any unexpected problems. So now how does this new platform over the past 1 year change how we build things and how we maintain things? It helps us a lot when we have new team members, but it also helps old team members that you only have to know one language and one framework. Now, you can know 10 languages and 10 frameworks. That's not a problem. But you cannot master 10 frameworks and 10 languages. That's a problem. Even you can master them sequentially, you cannot be a master in many of them at the same time. So this really helps also in a way that you don't have to do context switches as a developer. So as a developer, when I'm coming into office and I start working, I'm not preparing myself and getting into the PHP side of the product, or I'm getting into the JavaScript client side of the product, and then, oh, this is a PHP problem, and then I have to talk to the PHP guy, or I have to, go there myself and see what's going on in the PHP side. No, it's not like that. I'm just working on the product. So that's pretty cool, because it makes life easier as an engineer, that the product is now really like, there's not this big barrier between client and server anymore. Further, it allows us to, now the new platform allows us to postpone design decisions. For example, sometimes you see people, they refactor everything to render on the client because rendering on the client is now faster. And then 2 years later, they refactor everything again because rendering on the server is now faster. That's something that with this kind of platform, we can get away with because we have the same execution environment or very similar execution environment on the client and server. Therefore, we have the same templates and also we have the same rendering engine. And that allows us to switch very flexibly between where we render. So we can postpone such decisions and we can also delay them. Same goes for any other piece of logic that I write and I intended for the client side. If I realize it should have been on the server, it's just a matter of minutes. It's not a rewrite to get it onto the server. And also, deployment and resource allocation has become easier with the Manhattan Cloud because you can easily add and remove nodes and if the demand increases for your application. So from not only my talk, but from this whole year and from the talk by Kennedy and Eugene, I think we can conclude that this platform works really well for us, and it does not only work technically in the data center and on our notebooks, but it also works really great for us as engineers. It's been an incredible 1.5 years that we've been working on it, and it's been a lot of fun to bring a new platform to Yahoo and to scale it and to see how we can solve all those challenges that I've just described. So thanks all of you for your attention and being here on behalf of the Axis team and my fellow engineers. Thanks.